Hello again, this is a Chapter 7 video, and in this video we're going to be looking at subtyping, casting, and applying those ideas to the Network version 2 project. So first of all, a little bit of revision just to get the idea of these polymorphic variables and subtyping. So this is nothing new in this bit here. As you know, we define an area in memory for a type, so we could have a type of int or a type of student called x and s respectively. We can then assign something to that area. So in the area for x, which has been already defined as an int, then we can give it the value of 3, and similarly for a student. The other thing we can do is we can also assign them on previously created variables. So for example, if we've got int x, then we can make x equal y, or if we've got student s, then we can make student s equal student s1. So that's just revision, just to try and place where we're going to go with this. Object variables in Java are polymorphic, so that means that they can hold objects of more than one type. Variables can store subtypes of the declared type. So in our project, when we're looking at posts and message posts, this means that we can store, if we create a variable of type post, then we can store a message post in that variable. Without casting, which we'll look at casting in a minute, you can't hold supertype. So if you create a variable of type message post, you cannot hold a type post in that variable. So let's have a look at this a little bit further. Further revision here, classes define types. So we have our class, and then the class defines a specific type of object. Subclasses define subtypes, so a subclass of a class will define a specific subtype of that object. Objects of subclasses can be used where objects of supertypes are required. So this is what we've just said in the previous slide. This is called substitution. That's what that is, the name for that. So let's have a look at subtyping and assignment. Here I've got an inheritance hierarchy of vehicle, and car and bicycle inherits from vehicle. Now what we can say is we can say vehicle v1 equals new vehicle. That's fine, because that's storing the same type. The variable is storing the same type. Vehicle v2, so vehicle v2 is assigning an area in memory for a type vehicle. However, what we do is we assign it as a car. So this is a type saving a subtype in its variable location. And then similarly with vehicle v3, so again we're defining a vehicle type variable. However, in the vehicle type variable we are storing the bicycle object, which is a subtype of vehicle. So with that in mind, let's have a little think about casting. So we can assign subtypes to supertypes, as we've just shown, but we cannot assign supertypes to subtypes in the same way. So consider this idea. So let's create a vehicle V. So we've created an area in memory to store vehicle types. We now create another area in memory called car, called C of type car, which stores cars. We then assign a car in that particular variable. Because vehicle V is a supertype of car, then we can store car types in that. So V equals C is correct. So now consider this. C, because V is now equal to C, C can we not have as equal to V? Because V is of type car now, even though it's defined as of type vehicle, but it's storing a type car. So can the car point to the vehicle definition, or the vehicle variable? Now at this point, this is where the program has a problem, because we said that the rule is that subtypes can be used where a supertype is defined. Now what we're trying to do is we're trying to use a subtype to store it in a type which is a supertype, even though that supertype is storing a subtype in it. Now, because we know that, we can use what's called casting. So only when you know that a supertype is actually going to be used, or a subtype is actually going to be used, can you use casting. If V is of type car, then fine. But if v is of type vehicle, this is where we come into our major problem. Then you'll get a runtime error. So casting, we can use casting, but it's sort of a shortcut around the rule. Remember, the rule which we started with was we can assign a subtype to a supertype, but we cannot assign a supertype to a subtype in the same way. So we can get around that rule by casting. However, use it sparingly, because it can lead to all sorts of runtime errors if somewhere along the way the assignment is not correctly done. So casting, we specify an object type in the parentheses, as shown there, where we've used the car type, and this is used to overcome what's called type loss. The object is not changed in any way, and then a runtime is actually check is made to ensure the object really is of that type. If it isn't of that type, then you'll raise a class cast exception. Now, in a later chapter, we're going to look at exceptions in detail, so don't worry about exceptions. Effectively, all you're doing is raising an error at this stage. Again, use it sparingly. So let's have a look at the object hierarchy. Now, the object hierarchy in Java, every object which you create is actually inherited from the object class. So there's already a hierarchy in place. Although we've been looking at creating hierarchies, there is already a hierarchy in place, and the root of that hierarchy is the object class and the object type. Now, you'll see in many class definitions and on the API, lots of methods where they take parameters of type object. That means then you can give it not only of type object, but of any type below that in the inheritance hierarchy, which effectively means anything. So if something takes a parameter of type object, you can put any object you want into that. So collections are polymorphic. The elements could be simply of type object if we wanted to. So we can create an array list of type object. That means that we can stick anything we want into that array list, any type that we want into that array list, because every type of object inherits from the object class. A type parameter limits the degree of polymorphism. So previously we had array lists of type message posts and type photo posts. However, we're going to go one up in the hierarchy now, and we're going to have an array list of type post. So that means we can't have objects, any object stored in it, because it's an object is a super type of post, but any subtypes of post we can have. So in our inheritance hierarchy, we've defined that message post and photo post are of subtypes of post, so we can store those in that particular array list. So here's our class diagram of our version 2, where we've got our posts and our subtypes message post and photo post. So the object diagram we're looking to aim is to have something like this. In the newsfeed class, we're going to have a posts array list, and so that's going to be of type post. Now, because it's of type post, we can store subtypes in that, and so we can store message posts, photo posts, message posts, and the different subtypes there. If we then wanted to create a new subtype of post, for example, the event post, which we considered briefly previously, then we could also add that in, as long as it's with the inheritance hierarchy. So we consider our first project, our version 1, we had these two methods in our newsfeed class. We had public void add message post, which took a message post type, and we had our add photo post, which took a photo post type. Now all we need is add post, and that will take a post type. We can call this method, shown at the bottom of the screen there, photo post, and create a new photo there, and then we simply, from our newsfeed type, we do a feed.addPost my photo. So although we've said that the parameter is of type post, we can provide that parameter with a subtype of the type. So here we go here, this is exactly what this is doing. Here we've got our method here, which is a public void add post, and then below there we've created two new types, which is going to be our photo post and our message post. Then we can simply use those, because they are subtypes of our super type post. We can use those as a actual parameter to that method call, to that external method call. So let's have a look at that and what it looks like in the actual application. So here's our newsfeed class. We define at the top there an array list of type post called posts. So now in this array list we can store posts if we want to, or any subtypes of posts, which in our case is photo post and message post. We then assign our array list of type post, and then we provide our add post method here. So that just simply adds any post to that array list. We can then use our show method, and we simply go through our posts as we do before. Now what we're looking at here is post.display, which is an external method call to one of our posts. So let's have a look at our post display. So let's just pick out our post, and that's our display there. So that will display anything that we have in our post. Now later we're going to show you that you can override methods and then use specific methods in more specific types, but we'll leave that for another lecture. Otherwise, there's some exercises there for you to get the hang of subtyping, and some extension exercises as well. See you next time.